Hi students, today let us discuss structure of diborane. Molecular formula for diborane is B2H6. It is a dimer of BH3. Then two BH2 units are linked by two bridged hydrogen atoms. See, two BH2 units. This one is one BH2, another BH2. These two are linked by two bridged hydrogen. These two are bridged hydrogen. So it has how many BH bonds? 1, 2, 3, 4, 5, 6, 7, 8. In order to form 8 BH bonds, how many electrons are required? 8 into 2, 16 electrons are required to form normal covalent bond. But here, however, diborane has only 12 electrons. How do you say diborane has only 12 electrons? Let me explain here. However, diborane has only 12 valence electrons and are not sufficient to form normal covalent bonds. Actually, required number of electrons is 16. Only 12 valence electrons are present. It is not sufficient to form normal covalent bond. That's why the structure is different. We are going to explain everything one by one. Okay. B2H6 is the formula. Boron atomic number is 5. Valence electron, number of electrons in the outer shell is 3. Here B2H6, 3 electrons in the outer shell that is involved in the bond formation, plus from hydrogen, each hydrogen gives 1 electron. So totally 6 plus 6, 12 electron. Only 12 valence electrons are present. That's why it could not form a normal covalent bond. Okay. Ground state electronic configuration. 3 valence electron, 2s2, 2 electrons and 2p, 1 electron. Excited state configuration, 1 electron is transferred here. So this one undergoes sp3 hybridization. Actually, only 3 electrons are present here. One hybrid orbit, this orbital is vacant. That is also involved in hybridization. That's why this is a special case. sp3 hybridization takes place. So how many hybrid orbitals are present? 4 hybrid orbitals are present. One hybrid orbital is vacant, empty. This one is important point. So in diborane, in one more question also it may ask, what is the type of hybridization takes place in diborane? sp3. Here one empty hybrid orbital is present. Okay. Then now hybridization. Now how 4 terminal BH bonds are formed. Let me explain you how 4 terminal BH bonds are formed. Here 2 boron atoms, hybrid, each boron has 4 hybrid orbital. 1, 2, 3, 4. 4 hybrid orbital. Another boron atom, it has 4 hybrid orbital. Okay. Then this hybrid orbitals, these 2 hybrid orbitals combine with 1s orbital of hydrogen, they form covalent bond. 1, 2, 3, 4. 4 terminal BH bonds are normal covalent bonds. These 4 bonds are normal covalent bond. There is no problem here. It is normal. That is, this is the hybridization. That is for sp3 hybrid orbital, 4 sp3 hybrid orbitals. In that, one empty hybrid orbital is present. 2 hybrid orbitals are involved in the bond formation with hydrogen atom. 1s orbital of hydrogen and 2 of the off-filled orbital. This one is off-filled. Okay. 2 of the off-filled hybridized orbital of boron. This boron has 2 hybridized off-filled orbital and 1s orbital of hydrogen. They form normal covalent bond. 4 terminal normal covalent bonds are present. This one is also called as two-centered. Let me explain you. How normal covalent bond is formed here. 2 of the off-filled hybridized orbital of each boron. Off-filled hybridized orbital of boron combines with 1s orbital of hydrogen. Okay, it forms normal covalent bond. These 4 terminal bonds are normal covalent bonds. Okay. 4 terminal BH bonds are present. Normal covalent bond. They are also called two-centered two-electron bond. Why it is called two-centered two-electron bond? This one is one center, another center. Two electrons are involved. Two center, two electron. Two center, two electron. 4 terminal BH bonds are two center, two electron bond. It is easily represented by 2C2E bond. Then, now I hope you understand this normal covalent bond. Why it is called two-centered two-electron bond. Then, how bridged, this one, how, next one, bridged BH bonds are formed. That is the next one. The bridged BH bonds, how it is formed. Now each boron, see here, we know that 4 hybridized orbitals are present. 2 hybridized orbital, 2 sp3 hybridized orbitals are involved in terminal bond formation. What are the remaining one? Here one off-filled sp3 hybrid orbital and one empty sp3 hybridized orbital. These two are not involved in the bond formation. Only these two are involved in the bond formation with terminal hydrogen atom. These two are free now. What they are? They combine to form a bridged BHB bond. In the formation of bridged BH bond, this one is involved. See, this boron has one off-filled, this off-filled sp3 hybrid orbital and one empty sp3 hybrid orbital. Here there is no electron. This one is empty. This boron also has here empty sp3 hybrid orbital and one off-filled sp3 hybrid orbital. I hope you understand here. Students, here see, these two hybridized sp3 hybridized orbitals are involved in the bond formation with terminal hydrogen atoms. What are the remaining ones? This one, off-filled sp3 hybrid orbital and empty hybridized orbital, sp3 hybridized orbital. These two are involved in the bridge formation. Okay, not this terminal BH bond. This one. This boron has one off-filled sp3 hybrid orbital and one empty sp3 hybrid orbital. In the same way, this boron has empty hybridized orbital. Here there is no this boron hybridized orbital. But here off-filled sp3 hybrid orbital. This one belongs to this boron. Then, in order to form a bond, it needs 2 electrons. One electron from this boron, another electron from hydrogen. Hydrogen gives one off-filled 1s orbital. These 3 combine together and form a bridged bond. The same way, this one is not, it is an empty sp3 hybrid orbital, but this boron has one off-filled sp3 hybrid orbital, and hydrogen gives one 1s orbital. These 3 combine to form bridged BH bond. So these 2 bonds are bridged bonds, BHB. One bridged bond, another one bridged bond. So this one is called 3-centered 2-electron bond. Why? This one is one center, hydrogen another center, another third center. 3 center, but how many electrons are involved? Only 2 electrons are involved. Actually B2H6 is an electron deficient compound. So here also B2 3 center 2 electron bond. One center, another one center, third center. 3 centers, but how many electrons are involved in the bond formation? Only 2. 3 center 2 electron bond, that is BHB bond. 2 BHB bonds are present. How it is present? By overlapping of half-filled hybridized orbital of one boron. This one is half-filled. Then empty hybridized orbital of another boron and off-filled orbital of 1s orbital of hydrogen. These 3 combine to form a bridged bond. Actually, the structure of bridged bond is banana shape. That's why it is called as, bridged bond is called as banana bond. This is the structure of diborane. So what are the type of structures present here? There are 2 BH2 groups, 2 BH2 units are linked by 2 bridged hydrogen. These 2 are bridged hydrogen. These 4 hydrogen atoms are normal hydrogen. Only these 2 hydrogen atoms are what? bridged hydrogen atom. Why bridged hydrogen atom? Why bridges? Why bridges formed? Because of because of deficiency of electrons. In order to form 8 BH bonds, it needs how many electrons? 16 electrons. But in diborane, only 12 valence electrons are present. That's why these two bridged bonds are formed. Okay, that's why we are explaining. These 4 hydrogen atoms are normal. We are not going to explain in detail about these 4 normal hydrogen atoms. Mainly we are going to explain the bridged hydrogen atoms formed because of electron deficiency in diborane. I hope you understand this point clearly. This is very important 5-mark question. If you understand the bonding structure, you can write on your own why this what is normal covalent bond, what is bridged bond, how it is formed. If you know these points clearly, you can write on your own. Okay, thanks for watching. We will see you in the next video.